Welcome to my channel. In this video, we are going to see about types of optical fiber in fiber optics. Types of optical fiber. Optical fiber can be divided into two types. One is step index fiber, another one is graded index fiber. In step index fiber can be further divided into two types. One is single mode step index fiber, another one is multi-mode step index fiber. Whereas graded index fiber can be divided as multi-mode graded index fiber. Let me see one by one. The first one is step index fiber. This is the cross section of optical fiber. The central part of the optical fiber is core and outermost part of the optical fiber is cladding. Here N2 represents the refractive index of core, where N1 represents the refractive index of cladding. We have a greater refractive index of core when compared to the refractive index of cladding. That means N2 is greater than N1. So I have drawn like this. We have a higher refractive index N2 when compared to this N1. In the step index fiber, the refractive index of core is uniform. Throughout the core itself it is same. It is similar. Does not change inside the core. So the refractive index of core is uniform throughout the core. That means, for example, at the fiber axis the refractive index value is 1.5 means here also at the end of this core also the refractive index value is 1.5. At every point the refractive index value is same. Throughout the core it is uniform. So I have drawn like this. N1, I have drawn N1 here and N2 here. If we join these two lines, we have step-like structure. That's why we call it as step index fiber. Next, this is the signal propagate inside the optical fiber. Here it follows zigzag path in step index fiber. That's all about step index fiber. Next one is graded index fiber. And this is the cross section of optical fiber. The center part is core. N2 represent refractive index of core and outer part cladding, N1 refractive index of cladding. Here, the refractive index of core is made to vary as a function of the radial distance from the center of the fiber. That means, inside the core, the refractive index value is not similar, not uniform, not constant. That means we have different refractive index value inside the core itself. For example, at the fiber axis, the refractive index value is 1.5 means, and gradually it moves 1.4 and 1.3 and 0.5 and 0.4. That means the refractive index value is gradually decreasing from the fiber axis, right? According to the radial distance, it is gradually decreasing. That means the refractive index value is degrading. That's why we call it as graded index fiber. In graded index fiber, the refractive index value is not uniform. We have different refractive index value. In the fiber axis, we have maximum refractive index value. At the end of the core, at the edge of the core, we have a lower refractive index. It is gradually decreasing. So that is the main difference between graded index fiber and step index fiber. In step index fiber, the refractive index value is uniform, constant, but in graded index fiber, the refractive index value is not constant, it is gradually decreasing, right? And this is the signal propagation inside the fiber core. It follows a sinusoidal path. The next one is single mode step index fiber. This is the diagrammatical representation of single mode step index fiber. In this single mode means only one and mode means path. So we have only one path inside the optical fiber. In the single mode step index fiber, the diameter, core diameter is very small. So it can allow only one path, right? That is called single mode step index fiber. In multi-mode step index fiber, the diameter, core diameter is very large when compared to the single mode step index fiber. So we have a larger core diameter. It can allow multiple number of rays, multiple path. So that is the function of multimode step index fiber. The main problem we faced in multimode step index fiber is intermodal dispersion. That means, see here, we have first light ray can be reached at the end of the optical fiber, and second ray lost here itself. It does not reach up to the end of the fiber. So the ray can be lost here itself. That is called intermodal dispersion. This problem can be overcome by multimode graded index fiber. See here, and the light rays reach up to the end of the fiber cable. It does not lost any here itself. So multimode graded index fiber can overcome intermodal dispersion problem, because in this multimode graded index fiber we have a larger bandwidth, but in multimode step index fiber we have a lower bandwidth. So we suffer from this intermodal dispersion. So that's all about the types of optical fiber. Thanks for watching this video. Thank you so much, and please subscribe my channel. Thank